Let's review the quotient rule. Definitely one of the longest derivative rules. So we are looking to use this only if we have x's in the top and the bottom. So if we have something like f of x equals x squared over 4. This is not a quotient rule. We would just want to write this as being 1/4 of x squared, and that way when we take the derivative, we can just bring down the power, subtract 1 for the new power. 1/4 times 2 is 2/4, or 1/2, and then we just have x to the first power. Same thing if it was the other way. Not going to want to use the quotient rule on something like h of x is 4 over x squared. Now x is only in the denominator. We would say, well, this is the same thing as 4x to the negative 2. And now we can bring down the power and subtract 1 from the new power. So 4 times negative 2 is negative 8. X to the negative 2 minus 1 is negative 3. So just because we have a quotient rule doesn't mean we want to use it all the time. If you have x's just in the top or just in the bottom, it is not a quotient rule. But on the other hand, if you do have x's in both the top and the bottom, the rule says take the derivative of the top first. Order does matter since there is subtraction, and 10 minus 8 is not the same thing as 8 minus 10. So having that subtraction as being part of our rule here makes it so orders matter. So we need to take the derivative of the top first times the original bottom minus the derivative of the bottom times the original top, all over the original bottom gets squared. So if we look at an actual quotient rule, if we have g of x is 4x minus e to the x over ln of x plus 2x to the fifth. Now we have x's in both the top and the bottom, and we are definitely going to want to apply this quotient rule. We're going to call it g prime of x, and just go through piece by piece. We're going to have a derivative times an original, very similar to the product rule, but order matters. We need to take the derivative of the top first. So derivative of the top, derivative of 4x is 4, minus the derivative of e to the x is e to the x. So we have the derivative of the top gets multiplied with the original bottom. ln of x plus 2x to the fifth. So we've done that part. Derivative of the top, original bottom. Product always had a plus, now quotient has a minus. Derivative of the top, original bottom, minus. Now we're going to do the other derivative times the other original. So we're going to do the derivative of the bottom and multiply that with the original top. So derivative of the natural log of x is 1 over x. Derivative of 2x to the fifth is going to be 10x to the fourth. Bring down that power, subtract 1 for the new power. Now there's the derivative of the bottom. That gets multiplied with the original top. So original top is 4x minus e to the x. All over, we start with a quotient, we end with a quotient. We do the original bottom, get squared. ln of x plus 2x to the fifth, get squared. Derivative of the top, original bottom, minus derivative of the bottom times the original top, all over that original bottom gets squared. We're going to run through one more of these just because they are so long. I want to get the hang of it. Let's say we have y equals 2x minus 5x to the fourth over 3 to the x plus 13. Something with x's in both the top and the bottom means we're going to use our quotient rule, starting with the derivative of the top. I like to give myself parentheses to start. That way I don't forget any of these terms. I might have some extra space by doing this, but that's okay. I can always clean it up later if I want to. Here's my general pattern. Derivative, original, minus derivative times original, all over the original bottom squared. So we're going to work our way from the top to the bottom. Start with the derivative of the top. Derivative of 2x is 2. Bring down that power. We have minus 20x to the third. There's our derivative of the top, original bottom. 3 to the x plus 13. Quotient always has a minus. Now we're going to do the derivative of the bottom. Derivative of 3 to the x is ln of 3 times 3 to the x. Derivative of 13 is just 0. So we did the derivative of the top, original bottom, minus derivative of the bottom, gets multiplied with the original top. 2x minus 5x to the fourth. There's our original top. All over the original bottom gets squared. So 3 to the x plus 13 gets squared. And if you're confused about any of these derivatives along the way with e to the x, ln of x, or 3 to the x, be sure to review the other videos on logs and exponent rules.